Man, this chapter is so radical. Well, in this section, we're going to to do our best at solving equations containing radicals. This section 4 of chapter 10 is all about radical equations. We're going to solve equations containing radicals, and we're also going to identify extraneous solutions, and you'll find out what that is in just a second. So, getting going here, a radical equation is an equation that has a variable in the radicand. And again, the radicand is the number underneath the radical symbol. Okay? An extraneous solution is a solution of an equation derived from an original equation that is not a solution of the original equation. So you solve the equation, get a solution, but then when you plug it back in, it doesn't actually work. Which is weird. It does not happen often, but it happens with these radical equations. So let's start with solving radical equations. Here's an example. What is the solution of the square root of x plus 7 equals 16? Well, we're going to work through that example after going through the steps for solving a basic radical equation. So step 1, here's what I would say. Get the radical by itself on one side of the equation by adding or subtracting to eliminate everything else. Or dividing if there's something in front of it. But basically we're treating this whole part like it's a variable. Even with the square root, we're trying to get that by itself. Okay? So what we're going to do in this case is subtract 7 from both sides. Okay? Because that'll cancel that out. We have the square root of x all by itself equal to 9. All right. Step 2. Square both sides of the equation to eliminate the radical. So once the radical is all by itself, you can square it. Remember that squaring something and finding the square root of something are opposites. So that's why we're going to square it. So if we square it, square this side, and we square this side, that cancels out the square root, and we're left with just x here by itself. And that would be equal to 81. All right? Solve for the variable, which we just did. Now, if there's something else on the inside, we'd also have to solve it using those last steps once you get rid of the radical. But in this case, the x is just by itself now, and we want to check. So let's plug it back in to check. Checking is really important with these radical ones. If we plug it back in, we do the square root of 81 plus 7 equals 16. The square root of 81 is 9. It could be negative 9, but it is not. It works for being 9 in this case. And, sorry, that's not a negative. That should be a positive. Equals 16. That is correct, so we did it right. So that's the basics of solving a basic one with a radical. So why don't you pause it and try this one right here. We have, what is the solution of the square root of x minus 7, sorry, minus 5 this time, is equal to negative 2. Go ahead and pause it, and I'll show you the answer in a second, and then we'll move on. Alright, so checking this problem, I added 5 to both sides to get the square root part, the radical part by itself. Square root of x equals 3, and to get rid of that radical symbol, we square both sides because those are opposites, and we get x is equal to 9, and even when I checked it, it worked. So that is the basic radical equation. Now, let's look at solving with radical expressions on both sides. Just like you might have variables on both sides, sometimes you have radical expressions on both sides. So there's nothing to get rid of, like we said before. There's no extra thing that we need to add or subtract or divide from both sides. It's just radical on both sides. So what we're going to do is the same thing then. Step 2 is to square both sides. And that'll cancel out the square roots. So that we're left with 5t minus 11. And that's equal to t plus 5. Now there's no square roots because we just undid the square roots. We did the same thing to both sides. And we're left with no square roots. Now we just solve it like a typical equation. Subtract t from both sides. If you subtract t over here, you'll end up left with 4t minus 11 equals 5. I'm going to add 11 to both sides and get 4t equals 16. And then when I divide by 4, finally, I get the answer of t is equal to 4. Okay? And go ahead and check. I've got the square root of 5 times 4 is 20 minus 11 is 9, equal to the square root of 9. And I know I did a lot of that in my head, but you can double check that as well. All right, why don't you pause it and try one on your own. We got the square root of 7x minus 4 is equal to the square root of 5x plus 10. Go ahead and pause it and try it, and I'll show you the result if you unpause it. All right, so with this one, I ended up squaring both sides right away to get rid of those radicals, since there's only radicals on each side. And then I'm solving it like a regular equation. I got x equals 7. And if I plug 7 back in for both sides, you get the square root of 45 on one side and the square root of 45 on the other. And that means that we're good to go. So let's look at something, the second thing we talked about in our goal, or in our goals for today, our learning targets, which was the extraneous solutions. So let's read this through. When you solve an equation by squaring each side, you create a new equation, essentially, without the square roots. The new equation may have solutions that do not satisfy the original equation. So an extraneous solution is one that doesn't satisfy the original equation. Always check your answers to make sure you have no extraneous solutions. That's why it's so important to check, because sometimes, even though we solved it and we got an answer, or sometimes we get two answers, they don't always work back in the original equation. That's when it's called this extraneous solution. It's a rare occasion, but it does happen sometimes. So here's an example. We said we have, what is the solution of n is equal to the square root of n minus 12. So of course we're going to square both sides first to get rid of the square root, because that's by itself. So if we do that, we end up getting n squared equals n plus 12. All right, now how do you solve that when you have an n squared and an n? Well, we have to make it into a quadratic, like we did last chapter. So we're going to subtract n, and we're going to subtract 12 from both sides. So we have n squared minus n minus 12 equals 0. Okay, now we can take that and solve it like by factoring. What multiplies to equal negative 12 and adds to equal negative 1? I think it's negative 4 and 3. So we have n minus 4 times n plus 3 would equal 0. And using the 0 property of multiplication, we can set each of the factors equal to 0 and then solve it. So n minus 4 equals 0 and n plus 3 equals 0. And we get the n of 4 and negative 3. Now when we check, again, this is the important part, is checking. If you plug in 4, you get 4 is equal to the square root of 4 plus 12, which is square root of 16, which is equal to 4. 4 works. If you plug in negative 3, you get negative 3 is equal to the square root of 9. Okay? So in this case, it kind of works. Negative 3 does work because the square root of 9 can be a negative. If it's negative 3 times negative 3 equals 9. So maybe this isn't the best example in the world, but let's go on and do this one. You can do it on your own first if you'd like to pause it, and then I'm going to walk through it with you as well. So we're going to do the same thing here. We're going to square both sides. Y squared, or negative y squared, is just y squared. That's going to be equal to y plus 6. Now if we subtract that from both sides to make this a quadratic, subtract y and subtract 6, we end up with y squared minus y minus 6 equals 0. Okay, so we want something that multiplies to equal negative 6 and adds to equal negative 1. That would be negative 3 and 2. So we have y minus 3, y plus 2 equal to 0. So our two y values are positive 3 and negative 2 if you set them each equal to 0. So let's plug it in and check. Let's plug in 3. Square root of 3 plus 6 is 9. Square root of 9 would either be 3 or negative 3. Okay? Now that works. Plug in -2. Well, I should say it kind of works. Again, we want to deal with the positives. I know you can get a negative number when you take the square root of something, but most times when we're going to use this, it's going to be with real life examples, and the negative won't actually work in real life. So that's why the negative is actually not going to work. Or in this case, the 3 is not going to work because it's going to be -3 on the left side. If we plug in -2, you get the square root of 4, and that's going to be 2 or -2, and when you put that over that, it is 2. So we're going to say that this one actually doesn't work. That's our extraneous solution, because it doesn't always work. However, there are going to be some times when, so let's take a look at this. There's just no solution at all. And I'll show you why. When you have -8 from both sides, we have the square root of 3y equals -6. Okay? Now, think about this logically. Well, hold on. We're going to do this. We're going to square both sides. Sorry. I'm going to square both sides, and I get 3y equals 36. Subtract 3 by, or divide by 3 by both sides, and you get y equals 12. Okay, it seems like it works out, but let's plug it back in, and let's check. The square root of 3 times y would be square root of 36, so it would be 6. We have 6 plus 8 is equal to 2. No, 6 plus 8 is equal to 14. So this is where, again, kind of the extraneous solution, the only solution we get here doesn't actually work. So this does not work. There is going to be no solution for this one. So why don't you try it? Same idea here. See what happens when we solve for 6 minus square root of x is equal to 10. You can go ahead and pause it. All right, so when you solve it, you end up getting x equals 8. And if you plug that back in, I did some of that in my head again. 2 times 8 is 16, so the square root of 16 is 4. You get 6 minus 4 is equal to 10, and that is not true at all. 6 minus 4 is equal to 2. So that's where your only solution is an extraneous solution, which means there is no solution for this one. Okay? All right, so those are the unique situations when we're solving square root functions. Now, I do have a real-life example here where it deals with the pendulum of a clock. If you've ever seen like a grandfather father clock, you see the pendulum going back and forth. And there's actually this formula here. It's pretty interesting that T is the time in seconds it takes for a pendulum to complete a full swing. All right? And L is the length of the pendulum in feet. So there's a formula that would figure that out. It's the time is equal to 2 times the square root of the length of it divided by 3.3. For some reason it works, interestingly enough. In this example, it gives you the length of the swing, and you have to figure out, sorry, the time it takes to do a full swing, and you have to figure out the length of the pendulum. We're not going to work through this one right now, but it is a very realistic, very real formula that's used in science that deals with pendulums. Very interesting to me. It has to do with radical equations. But I'm going to leave you with one question at the end here. It says, a student solved the equation r equals square root of -6r minus 5 and found the solutions to be -1 and -5. Describe and correct the student's error. So go ahead and try that. And then revisit the goals. We have two goals. Our learning targets were to solve equations containing radicals. We did that. And identify extraneous solutions. We also did that. So that's that for section 10.4. Hope you guys did your best to do your best at solving at radical equations. Take care. We'll see you next time.